All right, today I'm going to work through some of the homework problems. All right, I'm going to do chapter 14, number 72. All right, so that is N2 gas plus 3H2 gas is in equilibrium with 2 NH3 gas and they give us the K value. We're at 450 degrees Celsius. And so Kc, equilibrium constant Kc is 0.159. All right, so this is going to be initial change equilibrium problem. All right, so for nitrogen, there's 1 mole in a 2-liter vessel. So that's 1 mole in a 2-liter vessel and 3 sig figs. And so that is 0.500 molar for your nitrogen. And then for your hydrogen, it was 3 moles in 2 liters. All right, and so that is a 1.5, and it's 3 sig figs, so 1.50 molar. And then we didn't add any of our NH3. All right, so we know that it has to go to the right because you cannot have a 0 at equilibrium. So the change, minus the coefficient of 1x, minus the coefficient of 3x. And then it's going to be going to the right, so then it is a plus the coefficient of 2x. So at equilibrium, you have 0.500 minus x, you have 1.50 minus 3x, and you have 2x. When we write our equilibrium expression for Kc, it is your products, concentration NH3, everything here is a gas, everything is included, squared over concentration of nitrogen, and the concentration of hydrogen raised to the 3rd power. All right, and so now we're going to put in our equilibrium conditions. So for the NH3, we have 2x, so it is 2x squared. For our N2, it is 0.500 minus x. And for our hydrogen, it is 1.50 minus 3x, quantity to the 3rd, and that is equal to 0.159. All right. So this would be a very difficult problem to solve. This is a highly mathematical question here. All right, because you can't do the quadratic because it is a quartic equation that is next to the 4th equation. But if you see this mathematically, you can see the denominator can be combined. So we have our 2x squared. I'm going to take out, okay, so I'm going to leave my 0.500 minus x. I can factor out a 3 here. All right, so out of this, I'm going to factor out a 3. But if you're factoring out a 3, you're factoring out a 3 to the 3rd. So I'm going to factor out a 3 to the 3rd. And then I have a 0.500 minus x, also to the 3rd. And that is equal to the 0.159. All right, and so now when I combine my 0.5 minus x and my 0.5 minus x to the third, now I have a 0.5 minus x to the fourth. Forgot my parentheses. All right, so I have my 2x squared, and I have my 0.500 minus x now to the fourth. And then I have my 3 to the third, which I will just write as the number 27. And that is equal to 0.159. All right. So now what I'm going to do is I'm going to multiply both sides by 27. So I'm going to multiply this side by 27, and I'm going to multiply this by 27. And so I can get rid of my 27. Grab my calculator. 0.159 times 27, 4.293. So now I have my 2x squared, and I have my 0.5 minus x to the fourth. And so now I have a perfect square on both sides. And so I'm going to square root this side and square root this side. All right, so on the left, I have 2x over 0.5 minus x now squared, and that is equal to 2.072. All right, so when you have a number that is greater than 1, you should be doing the quadratic equation and not the successive approximations. If you left it as it was up here and said that the 0.159 is small, I'm going to do successive approximations. I believe it takes 20 approximations, so it can be done if you just plugged it in your original. So back up here to the original numbers when you put them in, right here. You can say 0.159 is small, x is going to be small, neglect your plus and minus x. This will take you from x1 to x2 to x3 to x20, and that's going to be your answer. Not until you did 20 successive approximations. So again, that's going to be a lot of time to do that, but that can be done. But again, it's going to take 20 times before you get a match. If you see that this is a perfect square and you do it this way, now you can use the quadratic equation. And so we are going to, okay, so we're going to FOIL this. So over here, I've got 0.5 minus x times 0.5 minus x. So I have 0.5 times 0.5. So that is 0.25. And then I have minus 0.5x minus 0.5x. You add those up together and you have a minus x. And then a minus x times a minus x is a plus x squared. And so when you FOIL that, you get, so it's this times this times that times that times that. All right. And so I'm going to rearrange it into the x squared minus x plus 0.25. And so here I have my 2x, and on the bottom, after you FOIL it, x squared minus x plus 0.25, and that's equal to 2.072. All right, so then I'm going to multiply both sides by that x squared minus x plus 0.25. Multiply both sides by x squared minus x plus 0.25. So on the left here, I've got my 2x. So that is gone. I have my 2x. And that is equal to 2.072 x squared minus 2.072 x plus 0.518. All right, so then I'm going to subtract 2x from both sides. I'm going to subtract 2x from both sides, and then I have it into the form I want. And that is in your x squared, x, and so you have to put it into your a x squared plus bx plus c is equal to 0 form. And that's where we're at here. 2.072 x squared minus 4.072 x plus 0.518. So now we have our A, our B, and our C. All right, and so then you have your negative b plus or minus the square root of b squared minus 4ac all over 2a. You do not have to memorize that. It will be given. All right, and so here is your a value. Here is your b value being negative. Here is your c value. So there's a, there's b, there's c, and we're going to plug those in and get our two answers. Again, one will be a possible answer, the answer. The other one will be impossible, an invalid answer. All right, so negative 4.072, so 4.072 plus or minus. When you take it squared, you don't need to have the negative, so simply put 4.072 when you square it. Doesn't matter if it was negative, it is now positive. You don't need to put that in your calculator. 4, and then A, 2.072, C, 0.518, all over 2 times your A, 2.072. All right, so let's do all right. So we're going to 4.072 plus or minus. Let's get a number for that. All right. That's going to be the square root of 12.288 all over your 4.144. And so then you take the square root of that. 5. Okay, so you have your 4.072 plus or minus your 3.505 all over 4.144. All right, so then you take your 4.072 minus 3.5. 0.567 divided by 4.144. All right, so here are the two answers for x, 0.137. Everything was 3 sig figs, so I'll change this one to 3 sig figs. All right, so 1.83 and 0.137. All right, so let's go back up to we have our two values for x. One of those is going to be the answer. The other is going to be an invalid answer. All right, so immediately I see 0.5 minus x, so that could never be 1.83 because that would give us our negative answer. And so you can eliminate the choice for 1.83. And so x is the other one, which is a 0.137. All right, and so the question on 72, the equilibrium constant for this, calculate the equilibrium composition. Okay, and so, all right, so you have your 0.5 minus the 0.137, that gives you a 0.363. So your N2 concentration at equilibrium is 0.363. All right, so your H2, 0.137 here is X. So 1.5 minus 3 times 0.137. All right, and so that gives you a 1.09 molar. So your H plus concentration, 1.09 molar, and then your 0.137 times 2, your 0.274. And that's for your NH3, that was H2, that's NH3. All right, so that's your equilibrium concentrations: nitrogen 0.363, hydrogen 1.09, and your NH3 0.274. You could plug that in to this equation here, your Kc, plug those numbers in, and you won't probably get exactly 0.159, but you will get very, very close. It should at least round to 0.16. That you get for that, but you've rounded a bunch of numbers getting to that point. It may come out to be 0.156, 0.158, 0.162. It could be definitely different, but it should be right there at the very close to the 0.159. All right, that's as hard as a question can get. That is the very hardest question. You could do successive approximations because it's less than 1, it's barely less than 1, and it takes a lot of successive approximations to get the answer to come out to be the 0.137. And so then you may not see that this is pull out a 3, and then some people pull out a 3, but they don't pull out the 3 to the third. So they're off by some factor because you just pull out a 3 instead of an actual 27. So anyway, mathematically, that is a difficult question. None of the questions on the test are quite that difficult. However, there may be one where you have to do the quadratic equation. Find an easier one. And some that if you don't see it mathematically, you can do the quadratic equation and get the answer. That's the usual case for the ones on the test. There will be some where it says you must do successive approximations. So you have to know how to do successive approximations. Let's do the one before that. It's not as hard, 14.70. All right, so this one is PCl3 reacting with Cl2 to give PCl5. All right, everything's a gas. So all of those will be labeled just like they are in the homework as gases. All right, and then your K value, all right, is 49. All right, so that is not less than 1. And so you cannot do successive approximations. This is a relatively large KC. Large is determined by the number 1. It's greater than 1, so it's a large number. It means more products than reactants. That means X is relatively large. You're going to have things going to the right. So we're at 230 degrees Celsius. That's only important because that's what the Kc value is at that temperature. At a different temperature, it would be a different value. All right, we put 0.4 moles in 4 liters of each PCl3 and Cl2. This time, for whatever reason, the moles are 3 sig figs, but the liters are only 2 sig figs. And so this is 0.10 molar, and this is 0.10 molar. All right, and again, we want the equilibrium composition. So initially, they didn't say anything for that one. All right, and so it goes to the right, minus the coefficient 1x, minus the coefficient 1x, plus the coefficient 1x. And so we have 0.10 minus x, we have 0.10 minus x, and we have x. The expression for Kc, all of them are gases. They are all included. PCl5, PCl3, Cl2, products over reactants. All right, and so now we plug in our equilibrium concentrations. So X for our PCl5, 0.10 minus X, 0.10 minus X, and that is equal to 49. All right, and so again, we can't neglect X. Our K value is greater than 1. And so here you must do successive approximations. I will try it in a different way maybe, but let's do we cannot do successive approximations. You have to do the quadratic equation. So we have to use the negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to get our two x values. One will be the answer. The other will be an invalid answer. It's going to give us a negative concentration. All right, so there's nothing mathematically here that you can do to simplify it. All right, we don't have a perfect square in the numerator. If we had a perfect square in the numerator, we already have a perfect square in the denominator, we could take the square root, but we do not have a perfect square in the numerator. And so you are down to solve this by your quadratic equation. So we have to FOIL the 0.1 minus x. So 0.1 minus x times 0.1 minus x. So you have to be able to FOIL. 0.1 times 0.1, 0.01. 0.1 minus x, so minus 0.1x minus 0.1x. Last time I went right to the minus 0.2, but you get minus 0.1 twice. All right, so then you have your plus x squared. So when you're done FOILing the denominator, we're going to put it in the form of x squared, and then minus the 0.2x, and then the plus 0.01, and that is equal to 49. And so just like we did last time, we got to multiply both sides by x squared minus 0.2x plus 0.01. X squared minus 0.2x plus 0.01. So that is gone. Cancel with that. All right, and so you have x is equal to 49x squared minus 9.8 minus 9.8x and plus 0.49. All right, and then finally, you got to subtract x from both sides to get that side equal to 0. So both sides, you have to subtract x. And so you have 49x squared minus 10.8x plus 0.49 is equal to 0. You have your A, your B, and your C. All right, so you plug it into the quadratic formula. You have your 10.8, so negative B, but B is negative, so that makes it then positive there. Plus or minus, you're going to square it, so you can put it as positive. It doesn't matter. If it says negative and you square it, it becomes positive. Minus 4AC all over 2A. All right, so now okay. So you get your 10.8, and then plus or minus, when you do this, you should get 4.54 divided by 98. All right, so here we'll do the 10.8 minus the 4.54 divided by 98. And over here we'll do the plus. So there's our two answers for x. One is the plus, one is the minus. So let's do the plus one first. And that is 0.157. And then we will do the negative one next. And that gives you a 0.0639. All right, so then we go answers. All right, we come back up, see if we can figure out which answer is the correct answer. Zero. All right, so when we see that we have a 0.1 minus x, all right, and we have an x value that can be a 0.157, 0.1 minus 0.157 gives us a negative concentration. That is an invalid answer. And so your answer is the other x value, which is a 0.0639. So there is your x value. And then 0.1 minus 0.0639, you get your 0.0361. And your 0.0361. So that's your concentration for both your PCl3 concentration and your Cl2 concentration. And then your PCl5 is the 0.0639 value. That is your molarity for your PCl5 at equilibrium. All right. Okay, let's try this another way and see if this works. All right, so let's say that you are really disliking, do I do this now? All right, so I don't recommend this for a lot of people, but hey, if you like this and you want to do it this way because you hate the quadratic equation, this way can be done. If you don't do it this way, you never do it this way, you're with most everybody else. Okay, so not sure that this is going to be easier for this problem. All right, so the key here is that if you have the same reaction, but now at the same temperature, what I'm going to do is I'm going to ask, what is the K value for this? All right, so again, I'm not changing the temperature. We're still at 230 degrees Celsius. All I did was I reversed the reaction. So what is the K value for this? How do we find this K value? When you reverse the reaction, invert it. So it's 1 over the 49. So now this is 1 divided by 49. All right, and so you might like this because the K value is small. People like small K values. If they want to do successive approximations, you have to have a small K value. So if the forward reaction is a large K value, the reverse reaction, when you reverse it, it's going to have a very small K value. All right, so this one is 0.02, 020. All right, so that gets you that. However, our starting concentrations were 0, 0.1, and 0.1. And this is where people don't like this way of doing things. All right. So what you can say is that it favors the reactants. And so what you would do is you would have a new initial. All right. So here is your given initial. The new initial is going to be, I know that this reaction favors the reactants. And so let's take it all the way to the left. All right, and so we're going to have a minus x, and a plus x, except we're going all the way to completion. All right, and in this case, they are both 0.1. So here it's going to be 0, 0, and 0.10. So the reason why people will not do this way is because of this step right here. You have your initial, you have a small K value, which you know that means that you're mostly reactants and not products. So what you have to do is come up with a new initial. You have to push everything to the reactant side until something on the right is 0. This is not an equilibrium in any sense of the word equilibrium. This is just a new initial. You gave me concentration of the products in this case. I'm going to make that the concentration of the reactants by completely going to the reactants because I have a small K value. All right, and so now you're going to do ice from the new initial. All right, so now you're at a change that is not going to new initial. Now we know that x, this x value, you can call this a different letter if you want. You can call it Ni. All right, so if you don't like x twice, Ni. So that means new initial. So all that's doing is getting me a new initial. All right, so probably better to not use the same letter. That gets confusing. So let's use a double letter, which means I'm going to a new initial. So I have my given initial. I want a new initial. I know it's mostly reactants, and so I'm going to put them to the reactants until something over here is 0. All right, so now I'm at my ice. So now it's going to go to the right, minus x, plus x, plus x. And I know that this is a small value. And so now I know x is small. All right, so now I can use successive approximations. So now I have 0.10 minus x. I have X, and I have X. All right, so then I write my expression for KC. It is PCl3, it is Cl2, it is PCl5, and now I put in my concentrations at equilibrium, which are X, 0.1 minus X, and that's equal to 0.020. And so here I will say 0.10 minus X, which is very small, is going to be about 0.10. I'm going to do successive approximations. And so we're going to neglect. We know it's going to be small. We're going to neglect it. Then we're going to plug it in. And we're going to do that until we get the same answer twice. All right, so it comes out to be X squared over 0.10 is equal to 0.020. And so X1 is 0.0447, but we just need 2 sig figs, 0.045. All right. So then we plug that in. Wherever you neglected it, it's got to be plugged back in. And so for X2, we have X squared over 0.10 minus 0.045 is equal to 0.020. If I don't clear out my calculator, I get an X2 value of 0.033. All right, so this is as high as the number can get. This is as low as the number can get. And so we're going to keep going until we get the same number twice. So now for X3, we have to put in that number, X squared over 0.10 minus 0.033 is equal to 0.020. And that gives you a 0.03637 to 2 sig figs. All right, so now we know that now as high as it can get is 0.037. So we put in for X4, we have X squared, 0.10 minus 0.037 is equal to 0.020. I'm not clearing out my calculator. I'm leaving the whole number there. And you get 0.036. We gave the last one to 3 sig figs where we didn't need to because our K value was to 2 sig figs. All right, so we're going to be a little bit different because we're using the 2 sig figs because the K value is just 2 sig figs. All right, so then the next one's going to do it. It's either going to be 0.036 again, or it's going to be 0.037. All right, so your X5, 0.10 minus 0.036 equals 0.020. Again, I don't clear out my number. And you get a 0.036. All right, so 0.036, we got it twice. All right, so do you like 5 successive approximations, or do you like the quadratic equation and foiling? Whatever. So let's see that we have the exact same answer. That's not the same X value we got last time, but the question wasn't calculate X. The question was calculate your equilibrium concentration. So we have our 0.036. And again, we would have to give our numbers last time to 2 sig figs like we are doing this time. All right, and so we had, let's rewrite that. We have our PCl5, equilibrium, PCl3. plus Cl2. So at equilibrium, it was 0.1 minus x, x, and x. So if you look last time, you will find that you had your 0.036 to 2 sig fig molar for Cl2. You had your 0.036 molar for PCl3, and you had your 0.064 to 2 sig figs for your concentration of PCl5. Our answer last time, it had it as 0.0639. However, your K value just had 49, not 49.0. And so we should have given it to 2 decimals, and it would be exactly the same. All right, so I don't expect anybody to do it that way, but if you understand that it can be done that way, that is a big bonus. So again, I do this. I don't expect you to do it, but I like to do successive approximations. I don't like to FOIL. I don't like adding X's and doing all that stuff. All right, so I like to do successive approximations. So anytime I have a large K value, I reverse the reaction. And I know now I have a small K value. I have to make a new initial, put everything to the left until something on the right is 0. And then I reach an equilibrium. All right, again, quadratic equation gave you exactly the same answer without those steps. But things you do need to know is when you reverse a reaction, what do you do to K? You have to know you are inverting that K value. Right. And anytime I have a large K value, I would say it goes to completion and then it comes back. And that's always what I would do. So here I have a small K value. It is going to go to the left until something is 0. So when I say it goes to completion, that means that something is 0, or in this case, both of them, since they were exactly the same, both of them went to 0. All right, and that concept is very important in the next few chapters. All right. Let's see. So Charlie's principles. All right, let's do some that are not so hard, and make sure you get the ones that are not so hard right. Not every problem is as difficult as those 2 problems. All right, so I'm going backwards for whatever reason. Now I'm doing 14.68. All right, so I have the equation N2 plus O2 goes to 2NO. Everything's a gas. All right, and the Kc is given 0.0123. So that's your Kc given. All right, and so it says initially it contained 0.85 moles, so initial 0.85 moles in an 8-liter flask. All right, and everything is 3 sig figs. All right, so when everything is 3 sig figs, you want to give your answer to 3 sig figs. 0.850, 8 liters. All right, and we didn't have any of our NO, and it says find the composition of the mixture when equilibrium is reached. All right, so this is not the easy question that I thought it was. All right, great. So this is just as hard as all the other ones. So now you can do it a couple of ways, and so this one is interesting. So this one can be done 3 different ways. I'm going to do it the way we haven't done it quite like this yet, but we've done it all of the ways. We can't reverse the reaction. We have a small K value. That is great. When you have a small K value, you have options. You can do quadratic equation, or you can do successive approximations. All right, I'm not going to do it either way for this problem. All right, so that is a 3 sig fig, so that's a 0.106, a 0.106, and 0. All right, so you can't have 0, so you have to go to the right, minus the coefficient x, minus the coefficient of 1x plus the coefficient of 2x. And so at equilibrium, we have 0.106 minus x, 0.106 minus x, and 2x. You write your expression for your Kc, and you have your NO squared over N2 O2. And you plug it in. You got your 0.123, and you plug in your equilibrium numbers. That is your 2x squared, and that is your 0.106 minus x. And again, your 0.106 minus x. And so instead of writing it twice, I'm going to do what I'm going to do. And what I'm going to do is now see that I have a perfect square. All right, so you can do your quadratic equation from this. You can FOIL that out, do all that. You can say x is going to be small, and I can neglect x, and I can do a number of successive approximations. Both of those will give you the exact same answer. Hopefully the way that you see is you have a perfect square. And so what you should do, the easiest way to solve it, you don't have to do it the easiest way. I recommend doing it the easiest way, is to take the square root. Whenever you have a perfect square, you take the square root. And so you would then end up with 0.111 when you take the square root of 0.0123. That is equal to 2x divided by 0.106 minus x. And so now you just have a simple algebra equation. 0.106 minus x, multiply on both sides. All right, so that is gone, and so you have a 0.0118 minus 0.111x is equal to 2x. All right, I'm going to add 0.111x to both sides. And so I have 0.0118 is equal to 2.111x. Then divide both sides by 2.111. So divide this by 2.111. And then I have my x value, and everything here had 3 sig figs. And so I'm giving my x value to 3 sig figs, 0.00557. All right, so again, if you did successful approximations, you would get that answer. If you did quadratic equation, you would get that answer. But if you see that it's a perfect square, you take the square root, and then you have a much easier algebra problem to solve. All right, we'll pick up there tomorrow.